Hello friends, welcome to our channel. In this lecture, I would like to explain example based on the Clapeyorn's theorem of three moments. See here, this is the question, that is example 1 based on this Clapeyorn's theorem. So a beam ABC of length 16 meters consists of spans AB and BC each of 8 meters, and this simply supported at A, B, C. The beam carries UDL of 40 kN per meter on the whole length. Find the reactions of the supports and support moments. See here, the question will be given very simple. This is the continuous beam. A, B, C. Both A, B, C are the simply supported one. So the span overall consists of 16 meters. In that 8 meters and 8 meters will be divided here. Both AB and BC consists of 8 meters and 8 meters. And the span consists of UDL of 40 kilonewton per meter over the whole span. Clear? You can take down anywhere 40 also, it's fine. Otherwise, you can take down 40 kilonewton per meter or 40 kilonewton per meter individually. So this is the given data in the question. For this one, we have to find out the support moments and support reactions. So based on the Clapeyorn's theorem of three moments procedure, first you can take down the equation MA into L1 plus 2MB into L1 plus L2 plus MC into L2 equal to 6A1 x1 by L1 plus 6A2 x2 by L2. So this is the general equation for the Clapeyorn's theorem of three moments. So already in the introduction class, I explained very clearly regarding this formula. But and again in the note point also I explained one more formula which is simplified based on this formula. Whenever UDL will be given on the spans on the simply supported beams like this AB and BC. At the time, what is your simplified formula you will get? That is MA into L1 plus 2MB into L1 plus L2 plus MC into L2 equal to W1 L1 cube by 4 plus W2 L2 cube by 4. This is the simplified formula whenever UDL will be given. Already I explained very clearly in the last lecture how this one A1 x1 bar will be taken based on the parabola. So on substitute that one in this equation A1 and x1. Finally it will be simplified to this equation. So you please go and watch that video, then you will get a clear idea how I will take this formula. So once we will get this one based on this equation, you please solve the support moments. So we all of us know that on the simply supported ends, both A and C are the simply supported ends. B is also simply supported but intermediate one. For intermediate supports you will get the final moment. But for end supports, both moments at A and C will be equal to 0. So what about this span length? L1 will be equal to 8 meters and L2 will be equal to 8. And what about this W1? W1 will be equal to 40. Similarly, W2 also will be equal to 40 kilonewton per meter. So substitute here. What about this MA into L1? 0 into L1 means 0 plus 2MB. What about L1 plus L2? Already I wrote here 8 plus 8 plus what about this MC? 0 into L2 equal to 0. And what about this W1 which is 40 into length of this span 8 cube by 4 plus 40 into 8 cube by 4. You please simplify this one. You will get how many times it will goes. You please simplify. You will get 2MB into 16 which is 32 MB. Similarly, after simplifying, how much you will get here? You will get around here, simplify 8 into 8 into 8 into 10 plus 8 into 8 into 8 into 10. Directly simplify by using your calculators. You will get around 10240. Finally, you take MB value outside. So which MB will be equal to how many times it will go? Around 320 kilonewton meter. So these are the moment or the support B, and the MA and MC will be 0. Okay. See here how you will get that one. So both the supports, here it will be 0, at the center it will be around 320 kilonewton meter, and again here it will be 0. So finally you will get a BMD diagram like this, which is fixed BMD. And similarly, what about the free BMD? For free BMD, how you will calculate? We know on the span AB, UDL is acting, you will get W L square by 8. If you simplify, how much you will get? 40 into 8 square by 8. You will cancel that one. You will get 320 kilonewton per kilonewton meter. Similarly, span BC also same loading, WL by L square by 8, 40 into 8 square by 8. So we will get both, one will be 320 kilonewton per meter. So you can draw that one also with same ordinate. See here, I am taking the same ordinate because for UDL, free bending moment diagram will be parabola for the UDL. Similarly, here also I will take with same ordinate. So this one will be 320 kilonewton meter. So this is how you can draw the resultant bending moment diagram. Again, what happens? If you want to find the net bending moment diagram, so this is on span 8 meters, this is on 8 meters. So if you want to find the net moment, exactly we can find the ordinate here, and then we can remove from this 320. Okay. So if you want ordinate here, what you will do? So you will take average 0 plus 320 by 2, around you will get 160 here. Again 320 minus 160 will be 160 only. So this is your net bending moment diagram value. Similarly, here also average of 320 will be equal to 160. So again you can remove this 160 in that 320. You will get around 160 kilonewton meter only. So this is how you can find out the net BM bending moment diagram value. So already in our channel, I explained for various loading condition how you have to find the net bending moment values for difficult one also. For UDL and center point load, it is very easy to find the net BMD value. But for eccentric loading condition and for moment, it is very difficult. So already I explained that also in our channel. You please go on through. You will get how to find easily for different models also. And so our first task is completed to find the support moments, and our next task is to find the reactions, support reactions in the sense what we have to find: VA, VB, and VC for the spans ABPC. Clear? We will see that one here. So if you want to find the support moments, it is better to take individual spans. So it is best way to find out individually. Take down vertical reaction at A here. Similarly, vertical reaction at B. So the overall span length will be 8 meters, and this one will be UDL. And again see, your moment A will be 0 at A, and at B there will be 320 kilonewton meter will be load will be acting. MB means sum of the moments MBA plus BC. Like that you will get moment plus or minus 320. For example, if you consider this MBA will be equal to plus 320 kilonewton meter, you consider this MBC will be equal to minus 320 kilonewton meter. For that one, you will take here one moment which is 320 kilonewton meter, which is clockwise for MBC, and MA will be equal to 0. So take down clockwise moments one side, anti-clockwise moments another side. So resolve all the moments up to A, that is sigma MA will be equal to 0. So means what about this condition? Taking moments about A means we have to resolve overall moments up to this point A. Clear? And again I am taking clockwise moments one side, anti-clockwise moments another side. See here, what are the clockwise moments acting towards A in the span AB, which is 320 kilonewton meter one will be acting, and again 40 kilonewton meter load will be acting downwards, and we have to resolve up to this one up to A, that is for UDL. What about the formula? W into L into L by 2, that is 40 into L into, that is 8 into 8 by 2. Okay, and again what about the anti-clockwise moments? This VB. So first of all take down this one will be VB1, because for span BC again we take VB2 and VC. Finally we add VB1 and VB2 there. Okay, so this is acting upwards, and we have to resolve up to this VB1 to A, that is force into distance. VB1 into this distance 8, force into distance, which is acting anti-clockwise towards A. VB1 into 8. So if you simplify this one by using your calculators, what you will get? VB1 will be equal to 200 kilonewton. Okay, once you will get VB1, again we, after obtaining VB1, that is 200 kilonewton, then take sigma V equal to 0, that is total vertical loads acting on this span, that is VA plus VB1, which is acting upwards, and this UDL will be acting downwards, that is 40 into 8, that is 320. So already we know VB1 value. Take down that one. VA equal to 200 equal to 320. Send this one this side. What you will get? VA equal to 320 minus 200, which is 120 kilonewton. Load is, vertical load is coming at A. And what about this VB1? 200 kilonewton load is reaction will be coming at B. And again in the next step you will take VB and BC span. I will show you how we will take. Again span BC, UDL is acting here, that is 40 kilonewton per meter. Span range will be 8 meters. So here we have to find VB2 and VC. So already I told you moment C will be equal to 0 and moment B will be equal to, which is 320 kilonewton meter anti-clockwise here in this span BC. This is MB moment. Okay. Again take down clockwise moments one side, anti-clockwise moments another side. So maybe some people will get how this 320 kilonewton movement you will get. So I will explain one more time that one. See here, See here. So you got around 320 kilonewton meter MB. So MB is the moment which is obtained 320 kilonewton meter here. So we know the condition. Sum of the moments at joint B will be equal to 0. If you get 320 means there will be two spans. One will be BA, another one will be BC. Okay. So we know the condition sum of the moments at this span will be equal to 0. So if the sum of the moments will be 0 means already moment will be taken as obtained as 320 kilonewton meter. So once you take this one will be plus 320 and this one will be minus 320. At that time the overall moment will be sum will be equal to 0. So based on this condition you take one will be clockwise, another will be anti-clockwise moment. So already in the concept only I told you at the support hogging moments will be occur. So based on the hogging condition I take down BA will be positive and BC will be negative and overall the sum will be taken as 0. Clear? Then you can come to the topic. So what are the clockwise moments acting? So you can take either towards B or C. So this time I will take C. So last time I resolved up to B. So here I will take total moments resolving up to this point C. See here what are the clockwise moments acting towards C. So this VB into 8 which is acting towards C will be clockwise. So that is VB2 into 8 plus is there any clockwise moment acting here? No. This UDL will be acting downwards and I am resolving means it will acting anti-clockwise towards C like this. Already another anti-clockwise moment 320 will be here. We can add both of these values, which is 40 into 8 into 8 by 2, which is W into L into L by 2 plus 320 kilonewton meter. If you simplify, you will get VB2 will be around so same value because of the symmetric condition. Your value doesn't change here. You will get 200 200 kilonewton. Okay. Then take down sigma V equal to 0. Sum of the vertical loads acting on the span, that is VB2 plus VC equal to 40 into 30. So VB2 and VC will be acting upwards and this 40 into 80 acting downwards. Load 40 kilonewton per meter load will be acting downwards. For UDL you can take W into L. So already we know VB2. Take down that one as 200 plus VC equal to 320. So take down VC outside 320 minus 200 which is 120 kilonewton. So these are the vertical reactions. So you take down all the reactions here. VA will be equal to 120 kilonewton. VB1 plus VB2 equal to VB which is acting 200 plus 200 which is VB equal to 400 kilonewton and VC equal to 120 kilonewton. So once you got the equation, so these are the vertical reactions on the span VA, VB, and VC. So after knowing the vertical reactions, it is easy to draw the shear force diagram. But actually our question is restricted to up to here only. So that is how to calculate the support reactions and support moments. So once support moments and support reactions obtains, already I shown how to draw the bending moment diagram here. So within some 3 to 4 minutes, I will show how to draw the SFD also. Maybe it will be useful for some another problems in the future. So for that purpose, I will explain here how to draw the bending moment shear force diagram. So this is the equation. So already we have all the reactions, so you keep aside that one. Okay, VA 120, VB1 200, all the things. So take down the reference line, that is 0. Clear? So here VA will be 120. So this point will be at A, this is at B, this is at C. So we are at A, which is here. So VA will be acting upward, means you take the straight lines upwards like this, which is ordinate up to 120. Somewhere VA is acting upwards, you will get positive movement, so that I am moving upwards. And again UDL will be acting downwards, that is how much, 40 into 8, 320 kilonewton acting downwards. So already we are at 120, and downward load will be acting 320. For that one, what we have to do, minus 320, 120 minus 320 upward. So we are at here, and again from here what happens, 320 load will be acting downwards, which is UDL will be acting downward, means we are taking minus 320. So what happens, if you take that one, we will get minus 200. So for positive you can take upwards, for negative you can take downwards. Okay, so you will get minus 200 somewhere here, downward side. Clear? So because of the UDL, always remember, for drawing the shear force diagram, you take the inclined line. Okay, like this, inclined line. And here also straight line upwards. Clear? And again, what we have to do, we are at VB, this position. And again from here, total load, first VB1, 200 kilonewton load will be acting upwards. See here, how I am drawing. Up to here it will be 200. Why? Because the ordinate here will be 200. From here to here it will be 200 only. And again we are at here, VB2 will be acting again, how much? 200 kilonewton meters upward, 200 kilonewton upward. So which is higher than that one. So you please draw the straight lines. Okay, which is higher than this one. This one will be around 200 kilonewton. So overall will be 400 from here to here, that is VB. See here, 400 kilonewton. And again we are at here, again downward load is acting at here, that is 40 into 80. So we know that is 40 into 8 will be 320, which is acting downwards, that is negative. So you please remove that. So we are at here, which is 200 kilonewton meter, and please neglect that one, downward load, that is 200 minus 120, which is minus 120 kilonewton. So minus in the sense, again we have to take downward side, which is here, that is 120 kilonewton at C. So again draw the reference line. So for UDL you can take down the inclined line like this. And again we are at C. At C there will be 120 kilonewton load, which is positive, means which is acting upward. So I will take upward load from here. See here how exactly it will coincide at the 0th position. So whenever you can find out the reactions based on the two spans, like VA, like AB and BC individually, you will get VA, VB1, VB2 like this, and finally VC. So for drawing the shear force diagram, you will get exact reactions it will make at that particular position. So if there will be some more continuous spans like CD and DC also, this method is very suitable to draw to find out the vertical reactions and to draw the shear force diagram.